Clock start.
So this is our clock. We have a power source hooked up to an oscillator, basically pulse oscillator, which we regulate, and it gives us a time output to the 100th of a second.
This is our battery and power source, and these chips right here read out to the digital displays our time in 100th of a second, 10th of a second, 1 second, 10 seconds, and 60 seconds or a minute.
Our escapement is part of the 555 oscillating chip, and it's going to feed us a pulse, which is like a 1 or a 0 in the digital world here, which is how these chips communicate. So the 555 reads pulses. Normally it's giving 0 volts, but when it pulses it gives 5 volts, a 0 or a digital 1. The width of the pulse and the time between the pulses is controlled by the resistors A and B. The period being the time between the two falling edges here, which is what our chipset communicates with, falling edges. The period between the two, the capacitance of the capacitor multiplied times the sum of the two resistances. So if we wire up this 555 oscillator in a clever way so that once it's triggered, it'll trigger itself, and this will be kind of like part of the pendulum and the escapement for our clock if we were to do a mechanical clock. Here it would send a pulse, one oscillation of a pendulum or so, and it'll send it to this first chip, which will count 1. And then it'll keep counting pulses until it reaches 9, and then it'll carry over and add 1 to this digit, and so forth down until it starts counting minutes. These chips will keep track of time in binary, but then we'll have to use these wires to send it over these other chips to convert it into something that can be read easily like a digital clock.
Okay, next is our regulator, which is resistor A, resistor B, and the capacitor here. The way the regulator works is much like the pendulum in a pendulum clock, where this chip, which regulates itself by sending charges through the resistors and the capacitor, and then the capacitor ultimately builds up with charge and then discharges, creating a pulse out of this timing chip, which then goes to the time indicator. The way we regulate the pulse length, or the time between pulses that we want, is through the amount of resistance we have in the circuit. So, the way the capacitor works is charge flows through this resistor, and the amount of resistance in both of these determines the amount of charge that flows to the capacitor. The capacitor then stores charge here and then releases charge through this resistor and up to the timing chip, which creates pulses regulated by this system here. So with the resistor with a given resistance, it'll cause the capacitor to build up charge over a certain increment of time and then discharge that to the oscillator, creating a time indicator. In this case, our clock generates pulse widths of 1/100th of a second.